Hello, my name is Ron Gonsalves, and this is my digital sampling lab presentation for AE 2610 Group A02-X. The lab took use of a digital acquisition system, or DAC for short, consisting of a lab jack measuring device and its corresponding software, a microphone, and also a 3.5 millimeter audio breakout adapter for testing different audio samples provided. The goal of my conducted experiment was to test and analyze different settings on my Fender branded 15-watt amp and my Fender Squier guitar under different notes and chords. Data of the time history and power spectrum graphs were exported to CSV files, which were then analyzed and graphed in Excel. To initially start, the microphone had to be configured using an online tone generator. After successfully testing the microphone, the setup for the guitar experiment consisted of the microphone, amplifier, electric guitar, the guitar cord that connects to the amplifier, and all of this was placed in a quiet room to avoid noise distraction. The procedure followed playing and measuring a single G note, both in low and high pitches, and a C chord, one with gain and one without. Here are the results from the waveform identification section of the lab using the breakout adapter, where 11 tracks were played and the breakout adapter measured their time history and power spectrum in order to tell what type of signal was what. It shows the type of signal in the second column as well as their peak frequencies, and the other column consists of the smaller peaks that were displayed. Mainly, smaller peaks were shown in most waves other than sine waves. Table 2 shows the aliasing data of the sum of three sine waves, where the peaks were measured at different sampling rates on the track that was the sum of three sine waves. For my design experiment, I wanted to test how noise and certain conditions can impact recording equipment. Using the setup and procedure explained before, I was able to analyze data, including gain, EQ, and distortion on a signal. The first dataset explored the spectral and time domain differences between a high-pitched and low-pitched signal note on the guitar. Specifically, figures 1 and 2 display the time history and power spectrum for a high G note, while figures 3 and 4 correspond to the low G note, which is one octave below. In the time domain, the high G note shows a waveform that dissipates quickly, indicating a faster decay in amplitude likely due to a shorter sustain and less energy in higher frequencies when I played the note. Two prominent spikes are also shown, indicating me playing the note twice during the recording. In contrast, the low G note exhibits a longer sustain in the frequency domain. Both notes exhibit clear peaks at their respective fundamental frequencies, as seen in figures 2 and 4. However, the low G note has an additional smaller peak near 190 Hz. This likely corresponds to the second harmonic in the note of G, which is around 196 Hz of the which is a common occurrence in string instruments due to the natural harmonic excitation when pressing down on the fretboard. The second dataset examined the effect of amplifier gain on a C major chord triad and comparing the chord played with and without gain engaged. When gain is applied to an amplifier, it introduces nonlinear distortion that alters the clean nature of the input signal, adding harmonic content and noise. This behavior can be seen in figures 6 and 8, where the power spectrum for the clean chord, figure 6, can be seen with 3 clean individual peaks, indicating the C major triad, which is the notes C, E, and G. In contrast, the spectrum with gain enabled shows less defined and more distorted peaks, with additional noise and harmonics crowding the frequency domain. Furthermore, in the time history of the gain-on scenario, significant voltage activity is present even before the chord is played, indicated unwanted buzzing or amplifier hum. The signal in this case reached voltage levels near 4 volts, emphasizing how gain not only affects the played notes, but also introduces electrical noise into the system before and after signal input. In conclusion, the experiment was successful as all necessary CSV files were collected and produced accurate charts for analysis. The data confirmed that the amplifier responded distinctly to adjustments in the normal EQ knobs and gain EQ knobs. The highest peak occurred when the treble knob were turned up, while the gain settings resulted in a noisier spectrum. Minor complications such as mic placement and connector cord quality may have affected consistency, but do not hinder the overall validity of results. Something to consider testing in the future is using maybe a different type of electrical guitar or maybe an acoustic guitar and comparing that to an electric guitar, seeing how different guitar strings affect results. I used Elixir strings in this experiment and using and testing different watt powered amps or different branded amps. That concludes my presentation. Thank you for listening.